Good evening, my name is Gui Jingheng. Today I want to present about my topic, which is people are common as ESG trade. So my main inventor is Associate Professional Dr. Dave Pelling. So this is the outline for my today presentations. Carbon black market, as you can see, from 2022 until 2028, it can achieve about 31.50%, which can show that the market of the carbon black has a high potential to apply in several applications. So that's why we want to try to improve the properties of the recovered carbon black. So firstly, I will discuss about the three phases of our version of our product. So first one, we want to try to use the innovative ESG trade using the epoxy resin plus the RCB to achieve a better conductivity and also the sustainability of the product. Next one, we want to try to promote our product to target in the electronic industry because they want to have a cost-effective, high-performance, and also the eco-friendly ESD protection solution. And the next one is we want to have a scalable, sustainable, and also cost-efficient to offer a strong ROI and also ESG benefit for the investor. So what is recovered carbon black? As you can see, our product is provided by the Eco Power Synergy Sendirian Bahan. So actually, this product is derived from the waste rubber tire through the incineration process. And through this, we can substitute the traditional carbon black to achieve higher properties of our products. I want to choose the RCB because based on this graph, you can see that it shows better properties in the spec of the lower cost, high temperature stability, eco-friendly, easy to recycle, and also they can withstand the higher temperature environment compared to the current ESD. So this is the application of the recovered carbon black. So mainly they can use for the plastic tray, they can use for the conductive additive in the lithium-ion batteries, automotive parts, and also the pigments. First of all, I want to discuss about the problem statement of our research and how we want to solve our problem. So the first issue is about the current ESD tray. As you know, ESD tray is made from high-performance polymers, so this can cause a higher production cost. However, the higher performance polymer has a low thermal stability, means that they can melt at high temperature. So that's why we want to use the recovered carbon black because they can act as conductive filler. Based on the previous research, they can help in increasing the thermal stability and also have a low cost. However, when we use the recovered carbon black, they can achieve a lower interaction between the matrix and also the filler. So this can cause the lower properties of our products. So that's why we want to promote the surface treatments to help them to achieve the better compatibility between the matrix and also the filler. Next, I want to discuss about the advantage of the recovered carbon black. So the first one, they have promotes the sustainability because we can reduce the carbon footprint. Next one, it has a lower cost which can lead to the lower cost of the production. And the next one, they can use for several types of the application. For example, the ESD tray. And also they can align with the SDG 11, have functional properties. And the last one, they can adapt to the market change because recovered carbon black has a higher market in the future. Okay, so first of all, I will explain about the surface treatment process, which is the single surface treatment. We will use the nitric acid, sealant, and also ammonia. First one, we will measure the mass of the recovered carbon black. After that, we will add with the nitric acid or the different chemicals and then undergo the stirring process using the mechanical stirrer, and then we will filter it 3 times and then put into the oven for the curing process, and the last one we will refine into the powder form. However, if you want to use the dual surface treatment, we can use nitric acid plus ammonia. For ammonia, we can use ammonia solution. And also for the sealant treatment, we can use the ethanol. So we will mix with the RCB and then mixing process and then put into the water sonicator, and then we need to filter same one. And then last one is the drying temperature for the different type of the surface treatment. And the last one we will refine into the carbon black powder form. Okay, so after our product is undergo the surface treatment, so we will do the sample preparation. So first one we will measure the weight of the carbon black, epoxy, and also the hardener. So first one, the carbon black will mix with the epoxy and then undergo the stirring process using the mechanical stirrer. And then after that, we will put inside the water sonicator. And then after that, we will add the hardener to make become solid. And then we will pour into the mold based on the dimension as already shown. And then last one, we will place in the oven to undergo the curing process. And then after we already make sure our product is already cured, so we will do testing, which is fracture, electrical conductivity, XRD, and also the fracture toughness. First of all, I will explain is about the fracture toughness testing. So we can see when we use the ammonia, it can show the higher fracture strength at about 50 MPa without aging and also after aging. For we use the dual surface treatment, it can also show, but for the nitric ammonia treatment, they can show the higher fracture strength in the both with and also without aging composite. However, the sealant and also nitric acids, when they combine together, they show a lower fracture strength. So from here we can see that when we use the nitric acid plus ammonia, it can show a better choice because they have a consistent performance and also reliability, which is important for the ESD application. So next one, I will discuss about the fracture tolerance testing. So basically, the fracture tolerance testing is you want to measure the material which can resistant to the crack propagation, and then you can determine how much stress can withstand before a crack begins to occur. So based on the graph, you can see that the nitric acid and also the sealant treatment shows a very lowest fracture tolerance for the both condition. So when we want to use the higher fracture toughness testing, we can choose the sealant treatment is more suitable. However, we can show that the sealant treatment actually is not very suitable because it has a lower thermal stability compared if we use the nitric acid plus the ammonia treatment. Even though they have a lower fracture toughness, but their thermal stability is better than the sealant treatment for the every kind of the testing. Last, I want to discuss about the result for the XRE testing. So based on the graph, you can see that the dual phase treatment, which is the nitrate and also the ammonia and also the nitric acid plus the sealant treatment, they shows the largest D-spacing. So larger D-spacing means that they can increase the interlayer spacing, the movement of the ions will also increase so that the ions can be transferred increasingly, and also they can help to improve the dispersion of the conductive filler, and also they can improve the properties such as the flexibility, permeability. So from here we can see that when we have a larger D-spacing, they can help to maintain the consistency of the ESD performance. So next is the novelty of our research is 4 parts. So we can see that this is the first time use of the recovered carbon black with the several types of the surface treatment for our ESD tray. The next one is we know that we use the recovered carbon black can use to substitute the virgin carbon black and also the metal coatings. So this can promote the sustainability of the products. The next one is we can use the surface treatment to achieve the higher conductivity control. And the last one is it have a higher performance, which is the superior durability over the traditional polymer-based ESD tray. What I want to discuss is about the commercialization of our product. So first one is we can reduce the material cost because we use the recovered carbon black. The next one, recovered carbon black can promote is a eco-friendly solution, can reduce the waste and also the lowest carbon footprint. And also the recovered carbon black can promote the higher conductivity, durability, and also the strength of our product. And the last one is act as a crucial component for our electronic and also the semiconductor application. So it can source a higher market demand. So based on our conclusion, we can see that after we doing the experiment, we can show that when we use the nitric acid and also the ammonia, it can show the best overall mechanical properties before and also without aging. For the nitric acid plus the sealant treatment, actually they also show the improvement in the recycled carbon black integration inside the epoxy matrix. For the sealant treatment, actually they can show the maximum electrical conductivity, but it shows the lower thermal stability. So from here, we can see that when we use the dual treatment, can offer a superior balance of the strong conductivity and also the longer PVT, which is suitable for the electronic industry.